Welcome to lesson 8. Today we'll look at the first Turtles video. So what is the Turtles module and what can we do with it? The Turtle module or the Turtle library is another Python library, just like the random library that we looked at. It's a visual module and you can use it as a canvas to draw and create shapes. You can use it to create shapes and simple designs, as well as to create patterns and more complicated shapes. So, how do we import and use the Turtle module? Importing the Turtle module is simple, and we use the import statement at the beginning of the program, just like any other Python library or module. Next, we need to assign a name to the turtle, because the name of the turtle is what it's identified as, and what it is called as, and it's best to keep this name short. And calling the turtle requires a certain syntax, which we'll look into. And you need to call the turtle every time you want it to perform an action, even if you have called it in multiple lines before. So this is why it's best to keep the name simple and short. Next, we'll look at simple actions with the turtle, such as forward, backward, turning, and pen up and pen down. Now let's see how to create a turtle. So first you want to create a new REPL, and then in the templates here type in Python, and Replit has this Python with turtle template which we can use. Now when it first starts up, the Replit will look like this, but for now let's just get rid of this and let's start from scratch. So firstly we need to import the turtle. So we can do that by using the import command. So simply import turtle. And this is case sensitive, so make sure it's lowercase turtle. And then to again assign a name to the turtle, we can use a simple letter or word. So here I'll use T. So T equals turtle dot turtle. So this will allow us to perform simple movements and create shapes using the T as our turtle. So now let's look at one of the most basic turtle functions, which is how to move forward. So the syntax for this is almost as if you're giving a command in English. So T dot, T here being the name of your turtle. So if you assigned it a different name over here, use a different letter or word over there. T dot forward, and then bracket, and that is basically your function. And inside of here, you want to write how many pixels you want it to go forward. So let's try 100 for now, and then we can run this program and see what happens. So as you see, the turtle, which started over here, just moved and created a straight line forward 100 pixels. Alright, so now that we know the basic syntax of how to define, import, and call a turtle, let's look at some of its other functions and simple actions. So let's get rid of this here. And another thing, just like the forward, is the backward function, which is almost exactly the same, except the turtle is going backwards instead of forward. So it has the exact same syntax except with backward instead. Now if we run this, again, now it starts from the center point, same as the forward, but now it moves back 100 pixels. And the tip of this arrow here is where the end of the line or drawing of the turtle is. Let's look at some turning. So the turtle can either turn left or right, and that is done with the t.left and t.right functions. Now in here, instead of the size of pixels that we looked at in the forward or backward, it's the angle from 0 to 360. So I can turn it left 180 degrees, which will make this arrow face the complete opposite direction. And then if I turn it right 90 degrees, it'll go back 90 degrees and the arrow will now face up. So let's see this in action. And there we go. It turned left 180 degrees first and then right 90 degrees. So now how about we create another line? So t dot forward over there, another 100, and let's see how that runs. So there we go. We just saw the turtle basically execute the simpler functions such as forward, backward, left, and right. And now let's get rid of this and look at the pen up and pen down functions. So for example, if you want to create a dotted line, you could go t dot forward 20, then t dot pen up, and this is the syntax for pen up, which basically means the turtle can move around the canvas without drawing a line. So then we can maybe do t dot forward 20 again, t dot pen down, which means it'll again start making an impact on the canvas, and then t dot forward 20 again. So let's see this in action. And there we go. It basically went 20 pixels, pen up, went 20 more without drawing anything, pen down, and then 20 again. So now that we have seen some basic actions with the turtle, let's go ahead to see how we can create some simple shapes and patterns with the turtle. Now that we have seen how to use the turtle and perform simple actions with it, let's take a step forward and let's look at how to create squares, triangles, and circles, as well as a dot. And then let's look at how to manipulate these shapes, such as their rotation, size, and where they're placed on the canvas. So first, let's look at how we can create a square. So, of course, a square will have the same number of pixels on every side. So we can start with forward 100. And we know that each angle in the square is 90 degrees. So basically, by keeping on repeating this, we can create a square. So t dot left 90. And you'll notice that this code, we basically need to just copy paste it 4 times. So if we repeat this code 4 times and run it, we'll see that it creates a square. Now, to simplify this, we can use for loops. So for I in range, now since we need to repeat this code 4 times, 4, and then simply copy paste the same code into the for loop. Now, instead of using 8 lines, we achieve the same thing in only 3 lines. So we can get rid of this and run. And as you can see, it does basically the exact same thing. Now, let's see how to create maybe a triangle. So now a triangle has 3 sides. So again, we can use the for loop, but now with only 3 sides. And we can go t dot forward 100 again. But now a triangle's interior angles are adding up to 360, so that means they're 120 degrees each. So we can turn it left 120, and that should create a triangle. Let's just move this forward so it doesn't overlap on the square. And let's see how it runs. And there we go. So it's basically the exact same formula where you choose the side length and then basically turn the turtle a set amount of degrees to achieve the shape you want. Okay, so we've seen how to create squares and triangles. Now let's look at how to create a circle and a dot. So for the circle, the simplest way is to just use the built-in circle function, where the value inside these brackets is actually the radius of how much you want the circle to be. So let's start with 100 radius, and if we run that, it simply creates a circle with a radius of 100. Okay, now that we've seen how to make a circle, let's look at how to make a dot. So similar to the circle, it is simply t dot dot, but then inside here, the value is actually the diameter of the dot, not the radius of it. So if we execute this, it simply creates a black filled in dot with diameter of 50. I want to introduce you guys to a turtle function called the goTo function. So This whole plane is basically a Cartesian plane with the x and y axis similar to a regular graph in math. So you could do t dot go to and then the x coordinate and y coordinate. So this at the center where it starts with to begin with is 0, 0. So I could, for example, make it go forward 100 with x and up 50 with y. So that is basically where it'll start. So let's run this again. And there we go. Instead of creating the dot over here, it goes to the specified area and creates the dot over there. Now, if we wanted to not leave this trail that we see here, we can just use the t dot pen up before it and t dot pen down after it. It creates the dot at 100, 50 without making a line there. Okay, now that we've looked at creating some simple shapes with the turtle module, let's look at some more turtle functions, such as customizing the background color of the canvas, filling in shapes, customizing the pen size, as well as the pen color. So, let's first look at the background color and how to change the background color of the canvas. So it's really simple, and now for this one you have to ignore what you named your turtle, because that is just basically this stylus that creates designs. To customize the background color, you need to write out turtle.bg color and then the color of your choice. So this turtle basically talks to the whole turtle library. Since this part of the turtle library that we use to create the shapes and draw doesn't have a background color customization. So for this, for example, I can write any color such as red, and you can also use a hex code here if you want. And now we can run this and the background color is now red. Now let's look at filling in shapes. Let's make the background color something more light like cyan. So now to fill in shapes, it's really simple, and it's similar to the pen up and pen down command. So you start with t.begin underscore fill and then end with t.end underscore fill. Now in the middle you can create any shape you want. So let's just do a circle for now. So t.circle will be a radius of 50, and let's run this and see. So as the turtle comes around and completes the shape, it fills it in with the color. In this case, the color is black, but you can also fill it with another color. So for that, before your begin fill, you can write t.fill color and then any color. So we can try red, and now let's run this. So as you can see now, instead of filling it with black, it went around and filled it with red. But now, this black border around is kind of annoying. So let's see how to change the pen color so that the whole circle would be red instead of just the filling. This is again very simple. You simply just have to do t.pen color and change it to a color of your liking. For now, let's do red to match the circle. And let's run this and see. And there we go. The border as well as the inside is red. That is it for this part 1 of the turtles video. In part 2, we will expand on our knowledge and look at more complex patterns using functions with the turtle library, such as how we used for loops to create the square. We'll look at how to apply that with the function to reduce our lines of code. And we'll also look at using the random library to create random patterns along with our loops and functions.